with us. So they do all kinds of interesting things, but they also have had a long history with us. I argue it's a coevolutionary history where they've basically shaped our cultures and we've helped shape their cultures as well. And just as an example, what Tony's drawn here is a whole bunch of different things through time of how humans and corvids, crows and ravens in this case, have interacted. So initially, ravens were around before people even evolved, and they were scavenging from predators like saber-toothed cats or big vultures and condors that were out at that time. And as we came along and started hunting, boy, the crows and ravens glommed right onto us. We were an easy mark, we were pretty messy, we left a lot of things around, and they got right in there and got them. And that probably forced us to be a little more attentive, to cache things, to hide things, to defend our foods as well. Not only from predators, but from scavengers like the crows and ravens we were evolving with. This led us to things like some of the legends we're familiar with here in the Northwest, like I said, of the raven who created the world and peopled it for his own amusement with us. And that stimulated lots of interesting legends and mystery, basically, in how people were having to deal with these animals who would not only motivate them, but also steal their salmon as it was drying on the racks. So lots of kind of plus and minus of these birds all the time through history. They challenge us, but they also motivate us. In Europe, they were heavily involved with scavenging people on early battlefields or after the plague had killed lots of people, for example. Ravens and crows were kicked out of towns. They were bounties put on them to get them out because they were seen eating corpses of humans. And the plague doctors wore masks that looked just like ravens, and ravens are kept now in the Tower of London as a symbol that the kingdom won't fall as long as those birds are there. In Scandinavian countries, there were ravens that basically informed their gods of the state of the earth. And in Asia, they really informed artists quite dramatically. They really appreciated the flocking and social structure and family structure of these birds and painted it in many different ways. Maybe you've seen this big screen of crows that is at the Seattle Asian Art Museum for a long time if you visited there. Fabulous thing as long as this room basically is of a huge flock of crows from the Edo period. And then on through modern times, motivating our films, from Hitchcock's The Birds and how now the bad omen of the raven and crow from medieval times is carried forth, and when something bad's going to happen in a film, you hear a crow calling in the background. Or we use them to name our sports teams after the Baltimore Ravens, for example. And now they're co-evolving with us in the city. And they're learning us, and they're reacting to people that are different, good or bad, in those places, and discriminating amongst those. And we've done some research on that, which I'll tell you about after we take a short break. But this coevolutionary process, we think, is basically fed back and forth. And these animals have culture like we do. They don't, as far as we know, they don't do great paintings or they don't have musical scores, but they certainly have culture. And for an animal, that's a learned behavior that's passed on from one individual to the other. And I forgot to mention when I was showing you that brain graph, that's one of the key components that I think makes these animals so successful. Not only do they have big brains, but they live a long time, 20, 30 or more years. During that time, they gather lots of personal information, but by being social, they also gather social information, learning from one another. So those three things together allows them not only to influence us, but also to adapt to us and to pass on what they know about us to others in their group, so they can learn to live with us in a more successful way. So the American crow, and these guys, are smaller, about, 16 inches or so tall. They're typically in groups. They're typically around people. They're rarely found away from people. They will breed in kind of regenerating thick forest, but it's usually within, a half a mile anyway of a picnic ground or of a town, like Alaska. And then ravens are half again as big, so they stand about 2 feet tall. They have a 4-foot wingspan. They're the size of a red-tailed hawk. Much larger bill. They have a wedge-shaped tail. Typically, you only see 1 or 2 ravens together, unless you're at a dead animal where you might see 30 or 40 together. And these, they have very different social systems. both crows and ravens. Crows tend to live in family groups and defend territories that they're basically on all the time. And they have permanently monogamous pair bonds, so same male and female together for life. Ravens do the same thing, but ravens kick their kids off of the territory after about a month or so, and that's probably because they make all that noise, yelling all the time. Get them out of there, and then they go on and they basically flock up at these rich food sources, whether it's an ag field or a dump or an animal that's been killed. And they are very vagrant for many years until they get a mate and settle down, or they find a territory and settle with the animal that's there, and then become territorial. Both of them you can notice maybe in the spring as the young are coming out. When the young are begging, you'll see them waving their wings, begging from an adult to get fed, and they'll have a pink mouth lining, both crows and ravens. The adults have all black mouth lining. So if you see a bird who's on your property calling and it's all black inside, that's an adult, probably a territorial pair that lives there with you. But the crow social system is more of a family group. They allow some of their young to stay for years and help raise other kids that they have. That kind of depends on the environment and how much food is or isn't available. So that's a little bit about the difference between the two. But in general, they have very similar responses to people. Ravens learn how to live with wolves and other things in the wild, and crows really learn how to live with people in the city. And that's what I'll tell you about here with some experiments we did. I know some of you said you had seen the nature program that we were a part of several years ago. And so I'll tell you about those experiments. And basically the idea here was that we noticed when we go out and catch our birds or go to their nests and study them, they'd act differently to us in the next time we come around. They'd hide from us, or they'd scold or run away, and they just seemed off-putting basically by our presence. So we thought they must be recognizing us. And I think anybody who's been around crows and ravens comes to the conclusion pretty quickly. They know who you are, if you've been good to them or if you've been bad to them, and they will let you know what they think. So we thought, well, we would just test it with an easy experiment. When we captured some birds on campus 10 years ago, I wore, and one of my students and I both wore this caveman mask when we caught 7 birds. And so as we catch them, we lure them into food, and then we shoot it sounds like a hunting rifle. It's a .306 blank. It shoots a big net over them and pins them to the ground. So a scary, traumatic thing for these birds. And for other birds that are around, other crows, looking at them, it looks like they've been killed. They're stuck under this net, and then up come running these cavemen. They grab them out of the net, and they're looking at us as we are taking their weights and measuring their wings and putting bands on their legs so that we can tell them apart. Standard kind of research things. But we did it wearing these masks for these birds. Then our idea was we would walk around campus with lots of other people, and we would walk around with the mask on, and we'd see if they would respond to us when they saw us next. The people would wear the mask. Well, that's a great question. He asked, did the people or the crows respond? Well, they both did. We were particularly studying the crow response, but believe me, I should have been studying the human response, because it was equally, it was amazing. We then did this, I'll just tell you about the university experiment. We've done this in Bellevue and downtown Seattle and all sorts of other places around. And basically, the richer the subdivision, the stronger the response by people to you wearing a mask. So we don't just wear one mask, we have a control. In this case, we used Dick Cheney. And we did this because, as you can see, it's a difficult discriminatory task. And it's also, we knew Cheney, if we used him as the bad guy to start, it would be kind of a biased experiment. So the caveman is bad, the Cheney is good. No problem, he was neutral to the birds. And what we found is that beforehand, in this panel here, before we did any trapping, whether we didn't wear a mask or wore Cheney or the caveman, we actually wore this hat with it, there was no response. The crows didn't innately hate the caveman. They weren't afraid or anything about us wearing these masks. After trapping, in response to the controls, either no mask or Cheney, again, there wasn't much response. A little bit of an elevated response to the mask, Cheney, even though he hadn't done anything. But the caveman, strong responses to whether we wore it with the hat, without the hat, just the hat, or upside down. They responded very strongly. And the way they responded here is that they attacked us and scolded us like they would a hawk or an eagle. They dive down from the trees, they give a harsh vocalization, and they try to move us out of their territory. They follow us and harass us, basically. So they can recognize, but what's interesting is that they continue to do this, and they actually increase the amount of recognition over time. So this includes data collected 2 days ago, at the very end here. So this is the point I got 2 days ago. When I walked around campus with the caveman mask on, 23% of the birds I encountered scolded me. I have not touched a bird on campus for 10 years. I haven't seen the caveman for a year. So he comes out about once a year in these last 4 or 5 years. I did a lot initially, and we saw a rapid increase from no scolding to about 40% of the bird scolding. That was increasing, and now maybe it's decreasing, or maybe it's just an outlier. I don't know. But we'll see with a few more points. But my guess is that it should start declining. They should. Most of the birds that were trapped, there's only 2 that were trapped that are still even alive on campus. And so almost all the birds that respond to us are birds that were not even born when we trap, and that certainly were not personally involved in the trapping. They might have seen it, but most of them learned it during these intermediate years by seeing other birds scold us. And when they scold, that attracts other birds in, so they come in and they participate in that mob, and that's how they learn this behavior. It's not like they go off and talk offline. Hey, there's this guy, he comes out about once a year, wait for him. But when they see it, those that respond attract others, and that's how they learn. And we know parents teach their young in this way, or I should say young actually learn from their parents' action in this way, and so do these unrelated individuals. Again, this is advantage of being social, and this is also an example of culture developing in a bird, and in this case it's really a culture of hate for this particular guy when he comes out on campus. We also now know from these brain imaging experiments where in the brain this behavior is seated, and it's the exact same place it would be seated in your brain. So again, here's that image I showed you, and what we do with these experiments is we catch birds, like we did with the caveman mask. We keep them on campus for about a month, and we feed them wearing a different mask. So we wear one mask, not the caveman, but a different mask when we catch them, and a unique mask when we take care of them in their cages. So we feed them and clean the cage. And then we can do an experiment. We bring the bird in over to the med center, down right where you'd have your MRI done. And we put him in a room, and we let him look out while he's processing some glucose with a radioactive label, while he's metabolizing that sugar. The radioactive label goes to the part of the body needing the most energy, and it stays there. And while they're metabolizing that glucose, we have them look out and see the person who caught them or the person who's been feeding them. And then we can anesthetize the bird, put it in a scanner, like you would if you had an MRI done, put them in a scanner and determine where that glucose with the radioactive label ended up, what part of the brain it ended up in. And that's what's shown in these graphs. So this is just the structure of the brain you see from the front part, the 2 hemispheres again. You're looking head on at the crow versus right through the middle of the brain and then the back part of the brain. And you see when they looked out and saw the threatening face, the coloration here indicates what were the difference in the brain activity of birds that saw one thing versus saw nothing in the room. In this case, looked out and saw the guy who captured them versus looked out and saw nothing in the room. And the amygdala of the bird's brain on the right hemisphere was what was most active. That's where most of that glucose ended up. That's the same hemisphere of the same structure in your brain that would be activated if somebody scanned your brain while you were looking at somebody you had learned was dangerous, or some situation you had learned was dangerous. In vertebrates, that's the part of the brain that's responsible for learned fears. And crows do it the same way we do. And in another experiment, when a group of birds looked out and saw the person who was taking care of them, the other hemisphere, to begin with, was activated in a different place here, the associative reward center. Not the amygdala like we saw here, but a different place. And that's the same thing that would have been activated, for example, in Pavlov's dog, when they heard a bell ring that was associated with getting fed. That same part of the brain, expecting some food reward. And these birds had learned just within a couple of weeks of being fed, even in a cage situation, hey, this person's a good deal. They're going to bring me a hard-boiled egg and hamburger and chicken patties every day, and I'm ready for it when they saw me in this experiment. So that's how they're able to distinguish between things like the caveman or a neutral person or a friendly person that feeds them, which a lot of people do in the urban setting. How about compassion? We think about the emotional center, the amygdala of the brain. We know it's activated for fear. How about compassion? And in this case, maybe some of you have seen, somebody was describing to me before the talk today of ravens gathering around a dead raven, making a lot of noise. And crows do that, to a large extent. How many of you have seen these gatherings, or what some people call funerals, around crows? A couple of you. So if a bird is killed, they all gather. There's a lot of noise often. Then it's very quiet. Sometimes sticks are involved and other things have been noticed in these. And then the birds leave as quickly kind of as they gather. And you might suspect that maybe they are paying respects to a lost friend or a mate. They could have been mated to this individual for 30 years. And there would be an emotional response, you would think, to a loss like that, like when we mourn. It could be that they're just sussing out an open territory, taking advantage of the situation. Hey, who's gone? I'm going to take that spot. Or it could be that they're learning about danger and learning that this is a reliable cue that something bad happened here, and I better be alert to what it might be and learn from this activity. So if that's the case, we might expect different parts of the brain to be activated. And we did this experiment. We didn't do it with an individual that the crow in our test knew, but what we did is we held a stuffed crow in a dead posture like this. We did it with a face, wearing a face that they had never seen before. So what they were getting at, you're in the cage now like a crow looking out and seeing this stimulus. And basically the question is, are you perhaps learning that this is a dangerous person or a dangerous place, by seeing that? Or are you mourning the loss of a crow? Or are you thinking about a social opportunity? And if you're thinking about a social opportunity, kind of the mid part of the brain would be active. If it's an emotional, that amygdala should be active. And if it's a learning event, maybe the hippocampus would be active. So what we found is that it was the hippocampus that was activated in this setting. Here's again what happened when they saw the person who caught them, the emotional response of fear. Was this part of the brain? Not so when they saw that dead crow. But instead it was the learning center, the hippocampus, which is suggested there at least one of the functions of gathering around a dead crow, one that you don't know, is that you're learning about a dangerous situation. They're probably learning that person. And in fact, I've had now a student has been studying this in the field, and she's demonstrated that indeed the birds do learn that person, because after they've seen a person holding a dead crow in the wild, if you come back to that place as that person wearing that mask again, they will respond negatively to you, even though you didn't do anything to those individuals. You were just in proximity to this dead animal.